In Chapter 3, we're going to focus on solving equations and also mathematical models, starting with Section 3.1, which is about simplifying expressions and combining like terms. A term is a number, a variable, or a product of a number and one or more variables. Terms in algebra are separated from each other by either addition or subtraction signs. Often a term has a number factor and also a variable factor. The number factor is called the coefficient. For example, if we look at the term 7x, this would be what we refer to as an x term because it uses the variable x, and the number that's in front of it is the number 7, which would be its coefficient. Implicitly, when we write something like 7x, it's not explicitly written, but it really means 7 times x. The x is just kind of a placeholder for a number. If you tell us a value of x, then we can plug it in and evaluate it, as we did earlier in the last chapter. But for right now, this is just an algebraic term. For example, if we look at the next thing, we have 9 plus 3n plus 4x. This is an algebraic expression that contains 3 terms, those terms being a positive 9, a positive 3n, and a positive 4x. Again, we can kind of notice them because they're separated by addition or subtraction signs. Oftentimes, too, within algebra, we will take the sign that's directly in front of a term to the left to be the sign of the term. So while you can think of this as like 9 plus 3n, we can also think of the 3n term as being positive because there's a positive sign in front of it. In example 1, we're given the expression negative 4x plus 12y minus 3. First part is, how many terms does the expression contain? And the answer is it contains 3 terms. If we list those terms separated by commas, the first term would be a negative 4x term. So that's an x term whose coefficient is negative 4. We have a positive 12y term. And then the last term we would have would be a negative 3. This last term we are going to refer to as a constant term. So if the term does not have any variable attached to it, it's referred to as the constant term. Our other 2 terms in this expression would be an x term and a y term. We already explained that the coefficient of the x term is negative 4, and the coefficient of the y term would be positive 12. Like terms in algebra are those that have identical variable parts. Like terms in an expression should always be combined in order to simplify the expression. So an example of like terms would be, for example, 5x and 8x. Because these have exactly the same variable part, that means that they're like terms, and we can combine them by doing the operations with their coefficients. 5 plus 8 would give us 13, and so 5x plus 8x would simplify to just the single term 13x. If you look at something different, like let's say 4x minus 3y, these 2 terms would not be like because one is an x term, the other is a y term. And so because they have different variables, they're not like terms, so we would not be able to combine them. Similarly, if I had something a little more in depth, something like, let's say, 3x squared plus 6x, even though both of them somewhat use the variable x, these 2 terms would be considered to be different because one is technically an x squared term, whereas the other is an x or an x to the first power term. So in order to be like, they have to have identical variable parts, meaning the variables have to be exactly the same, and in addition, the exponents would have to be exactly the same as well. In example 2, we're asked to simplify by combining the like terms. We know that the order of, in terms of addition, we know that addition is associative. So we can add the 7 and the 2 together here, which are like terms, because they're both constants, to get 9 plus x. So in example 2, part A, the answer is 9 plus x, or because remember addition is commutative, we could rewrite this and write it as x plus 9, which is more commonly how you would see that answer written. Traditionally in algebra, we tend to put the variable terms first, and if you have any constants, to put them at the very end or the back of the problem. Here in example B, we have 9 plus 3x plus 4. This is a variable expression that contains 3 terms, but of those 3, the 9 and the 4 are like terms. So we should be able to combine them. A positive 9 plus a positive 4 should give us a positive 13. So this would simplify to 3x plus 13. Let's get some more practice. In example 3, we're asked to first identify the like terms and then combine them. If I look at 3a, I notice that this expression has 1, 2, 3, 4 terms because they're separated by either addition or subtraction signs. And of those terms, 2 of them are like. We have 2 AB terms. So we have a positive 7 AB, and we also have a positive 2AB. Because they're like, we can add the coefficients. 7 plus 2 gives us 9, and it's an AB term. The 2 remaining terms would be that 4A and that 3Y, and they're not like anything else in the problem, so they can't be combined because they're not similar to anything else. So our final answer is 9AB plus 4A plus 3Y. If we go over to example B, this is an expression that has 1, 2, 3 terms. Of those 3 terms, these 2 would be like terms because they're both x terms. A positive 3x and a positive 2x would give us a positive 5x plus 7y. And that would be our simplified answer. Again, there's no constant term for this one, so we don't have any constant term to write at the end. And also a traditional kind of way to write things out is if you have multiple variables, we kind of tend to put them in alphabetical order. So we put the 5x term first, and then follow it by the plus 7y. If you write it as 7y plus 5x, that's also correct. Again, we know that because that would be the commutative property of addition, but this would be the standard way to write it. In example C, we have 4 terms this time. There's 1, 2, 3, and 4. And of those 4 terms, these would be the 2 that are alike because they are both m terms. A positive 14m combined with a negative 10m, 14 minus 10 we know is 4m. The 9m squared is a positive 9m squared, and then we have minus 1. And as we stated a moment ago, even though the 4m and the positive 9m squared both have a variable m in it, they are not like terms because they don't have exactly the same exponent. Also, so while this is the correct answer, you could leave your answer like this. Another convention that we use when writing our answers in algebra is if you have multiple powers, we always choose to write the highest powers first. So I'm going to write the 9m squared term first, then the 4m to the first power, and again saving the constant term for the very end. So final answer, 9m squared plus 4m minus 1. If we come over to here, part D, we have 3 terms. These 2 would be like. A positive 4xy and a positive 2xy will give us a positive 6xy plus 8y. Another very important concept we're going to talk about in this section to simplify is what's called the distributive property. The distributive property, you can think of it as a way to kind of eliminate parentheses by distributing the outside factor inside to every term that's on the inside of the parentheses. So in a way, what the distributive property is really telling us is it describes the way in which the operation of multiplication interacts with that of addition and subtraction. If I take this a, because it's multiplying implicitly, and I multiply it to everything that's in the parentheses, we're going to get a times b, which would be our first term here, and we would also have plus a times c. And it works exactly the same way if you're have a subtraction on the inside. A times the quantity b minus c is it's a times the first term, that's a times b, and then subtract a times the second term, which would be ac. Let's use the distributive property in order to simplify the sections below. The reason why we would not consider these to be simplified, again, is because we do have parentheses. So we would like to eliminate the parentheses by distributing. If I take the 6 and multiply it to each term in the parentheses, 6 times x will give us 6x. I can think of this particular multiplication as kind of being 6 times a negative 2, which would give us a negative 12. So our answer there is 6x minus 12. Coming over here, we want to distribute the 5 into this parenthesis. We do so by first taking the 5 times the 3y. That'll give us 15y. And then 5 times a positive 7 would give us positive 35. Building upon this, let's take a look at example 5. Here, there's a lot more going on where not only do we have a parenthesis, but we have additional terms that are kind of either added or maybe even subtracted on the outside of that. But again, think of your order of operations, your PEMDAS. We have to multiply first before we add. To multiply, I'm going to distribute into the parenthesis. 5 times 2x is 10x. 5 times positive 7 is positive 35. Notice that that 6x is not inside of the parenthesis, so it does not get multiplied to the 5. That 6x can come straight down. And this is great. We've simplified it by using the distributive property, but we're not all the way done. Because now that we've distributed, notice at this point we have 3 terms, and 2 of them end up being like terms, namely the positive 10x and the positive 6x. So we can combine those. 10x plus 6x would give us 16x plus 35. And now there's nothing more we can do. We're left with 2 terms, and they're not like terms, so we can't do anything more to simplify this. Let's take a look at the next example. Here we want to take and simplify this expression. Notice we have 2 different parentheses here, so we're going to have to use the distributive property twice. I'm going to first start by distributing 6 into the first parenthesis. 6 times 2x is 12x. 6 times 4y is going to be a 24y. To the second parenthesis, we're distributing in a positive 10. 10 times 4x is 40x. 10 times positive 3 would be positive 30y. Now that we're here, we do have some like terms. Namely, if we look at it, these 2 x terms are like terms, and also our 2 y terms are like terms. So let's go ahead and combine those. The positive 12x plus 40x will combine to give us a 52x, and then the positive 24y and the positive 30y should combine to give us a positive 54y. And that would be our final answer.